My name is Kevin Choi. I was doing the Analysis Center coordination for last almost 2 years now, and I'm so grateful to have this opportunity. This talk will be about more like about the transition to Geoscience Australia and MIT. So I'm going to talk about the transition and its current status, and then more important stuff about the future and the beyond. Tom will take care of that. So without the past, there will be no future. So I'd like to thank all the former analysis center coordinators. We had about 22 years ago, IGS coordination, analysis center coordination started. First coordination was from our Canadian fellows, NRCan, and then CODE, GFZ, and NGS. We did 2 4-year terms, and this is the end of the 4 years, end of second 4 years. And then now we are moving to joint effort between Geoscience Australia and MIT. And it's planned to be until 2018, is that right? But who knows? And then the TRF combination, there's work done by, first part was by NRCan, and then second part right now is done by IGN, French colleagues. And also we have another very important part, which is a GPS time scale analysis is done by Naval Research Laboratory in Washington, D.C. And this is done only for the rapid and finals. So this is just a brief status of the current product. This is the weighted RMS of final orbits, and this is the whole history of the weighted RMS. And this red box, this is a zoom in. And I just wanted to point out this around week. Okay, yeah, around week 1820, all the analysis centers who contributed to repro 2 switched their operation to consistent with the repro 2 modeling and the analysis scheme. So as you can see here, the inter-AC consistency became much better than before, and also this can be seen in the rapid weighted RMS as well. You can see here this inter-AC, the agreement is getting much better now. And more details about this kind of analysis will be shown in tomorrow's the plenary session, ACC plenary session. So stay tuned. We have quite a few of good presentations coming up tomorrow. And I'm going to switch gear to the transition. So new ACC search began in 2013, which is about 3 years ago, but has some hard time to find the new ACC. And finally, Geoscience Australia and MIT jointly submitted the proposal in September last year. And the key point of this proposal was to have a distributed effort for the coordination, because right now we have around the clock product, and somebody has to watch the quality, just like firefighters out there, wherever, even though there's no fire. So somebody has to watch and monitor the service. So that was the good thing about this proposal. And also, we have moved to the ACC server location to the cloud. So it'll make the future transition become more smooth and faster. Honestly, from yesterday we had some issues. Right now we have some issues with this main ACC server. So yesterday we had to switch to the new to the different zone to produce the product. So without this cloud environment, this could not be happening. So we were testing two different zones, one from Sydney and the other one from Frankfurt. Because as you can see in this map, there's no strong, thick underwater cable going from Australia to the United States and Europe. So there's some latency we have noticed. So that's why we decided to have the main server in Frankfurt and then have the backup in Sydney. So, so this is a summary of about this transition, and there was some under-job training in past November with the Geoscience Australia, Mike Moore. Special thanks to Mike Moore and Gorong Hu to bear with me, and this is the timeline of the duty transition. So right now, the red thing is not happening right now, but the ACC duty official handover already happened in early January, and then the official ACC email has been changed to igs.org domain name. And then January 14th, we had an official switchover of the product. And then the January, sometime around 20th, I'm not 100% sure about the date, but the web service is switched to the Amazon services. And then after this workshop, when I come back, my plan is to decommission the NGS server and then decommission this the current email address. And then the goal is unnoticeable transition. So hopefully you have not noticed this transition. So, and then this is one example of the analysis we did during this transition. We had 15-minute clock and then 5-minute clock and SP3 files. This plot shows the difference between the current operation and the new server operation. At the end of each plot, the transition happened at this time. And then, as you can see, there was some clock exchange, got some tiny bit of differences, which is less than 0.2 picosecond, which is we can ignore that. And in the final clock combination, we had some problems, and we were able to coordinate with the NRL people, and thanks to Mike Coleman, we were able to fix this problem. And ever since then, we had almost zero differences between the new and old product. So at this moment, I'd like to hand over to Tom, and then...
Can I ask a quick question? Can you go back to the latency map?
Right.
And do you have a legend for that to describe what the different colors are? Or will we talk about that tomorrow?
We can talk about it tomorrow, but you can just ignore these red things. But the blue and green, those are the underwater cables. Okay. And depending on how thick they are, how much they...
Capacity.
Yeah.
So big, thick lines are good. Thin lines are not necessarily good.
Thanks, Kevin.
Thank you, Kevin. Personally, I'd like to give a great thanks to Kevin. He's been absolutely marvelous over the last few months in doing this transition over and still working very hard. As he said, as everyone got in airplanes and decided to come here, Frankfurt decided to stop talking to the US for some reason, and we still do not know why. I'd also like to acknowledge Michael Moore, who's standing way up the corner there. He is the other half of this team. But as you might notice, he is sitting on a computer, and he's probably debugging the solution as we're running. And that is actually part of the reason that we have the appeal of this particular way of doing things. And I think this is hopefully going to work out very well over the next couple of years. The nice thing is we basically, batteries are running flat. We actually have sped things up, at least to Frankfurt. So the time delay we worried about originally was how long it would take the products to arrive. Or you can actually simply go down the time tags when the SP3 files are arriving. And what we found basically is that it actually has sped up over the switchover. And that's part of the reason is the protocols of going back and forth to NRL. That seems to have sped up. We think Sydney will be a little slower, but we think it's still going to be just in a matter of minutes to when SP3 files turn up. The finals, again, are being delivered on time. Those are actually run manually, and Michael actually handles doing that. It actually requires a setup. Everything else runs automatically, and we get emails, and hopefully they always say OK on them. And as I said, that seems to have worked well. We think the transition went very smoothly. The biggest problem we had was the emails, the lists of emailed people that get reports was too big for the Amazon services. They thought it was spam. We had to work actually how to get that to actually work out. And that all came out. OK, so just the general issues and comments. And we're going to come back to this tomorrow in the ACC session as we go across. I suppose our first thought when we did this was don't break anything. And I think we've succeeded in doing that. It is actually quite critical how many people use these products and how we have to worry about making sure they become available on time. Now, the issues we're facing in terms of this analysis is basically the adoption of the ITRF 2014 system, the issue of generating the consistent set of orbits and clocks going back to the beginning of the IGS. That's still up in the air. We will discuss that tomorrow. There is some scale differences that are developing, and it looks very much like we will now redo all of the satellite base center offset locations to be consistent with ITRF 2014. As many of you probably know, we need to keep the scale. We have been keeping the scale of the GNSS systems consistent with that of the ITRF itself by changing essentially the base center locations on satellites. As the ACs that are involved in here, this is a massive effort from a large number of groups of people who actually do all this data processing and do all the software updating, and particularly as we go into GNSS. So one of the critical issues we look at is what is the most important updates we should be doing? What model changes should we be doing? We want to discuss the issue of multi-day orbit arcs. That is something which the last ACC was somewhat reluctant to allow, didn't want to correlate between days. I'm not certain that's a valid point of view, so I'm much more open for the idea of us actually having multi-day orbit arcs while keeping everything else on a daily basis. Radiation pressure models and eclipsing models, those are still the bane of our existence in doing all of this GNSS modeling, particularly related to the yaw aspects of it. Loading corrections in various forms. Right now, we're not applying any. That's something we'll have to debate as time goes on and trying to make sure we understand what we're actually applying so that we can take it out if need be. Time-dependent gravity is something which is obvious in things like the GRACE mission, but now is getting more important for the GNSS systems as well, although since these are very high-altitude satellites, it's not quite so critical as it is for things like the ILRS, for example, the laser ranging system. Pull-tide corrections. And then there's an issue which comes as a lot of the models we're applying now actually require processing before them, and something like, say, the second-order ionospheric model corrections, which many of the implementations require a gridded version of the ionospheric delays. That is something which is difficult to do in the ultra-rapid, since no one's actually done that processing yet. And so how we go about implementing these models that require pre-processing as we go to near real time is something we have to address. Right now, something like the plate boundary observatory processing for the rapid product, which is a day old, we do not apply second-order ionosphere because the grids are not available. For the final products, which come out a couple of weeks later, we do apply it. And maybe that's a model we might end up adopting. We are in a resource-limited world in some senses. So how do we move forward to do a complete GNSS capability? That is a lot of software development. I can speak from experience with our software at MIT. We're going through that transition right now. And I must admit, Galileo and Beidou are relatively simple. Things like GLONASS, as many of you know, is much, much more difficult to do. And then finally, the issue, again, of having a fully operational process that handles both GPS, GLONASS, and all of the future systems coming out, Galileo and Beidou. And then the issue of how much do we wait for what is often being referred to as ACC 2.0, which is this new implementation of the combination software. Right now, what we have is a blend of different software packages. That's what makes this transition always difficult. And there is plans. People are working on the idea of having a fully consistent package. The GMEX project, for example, sort of leading the way in some senses in that, and how we go about actually getting that implemented into the operational software. So as I believe that is no backup slides. So.